Question 4. It's asking us to calculate the GPE. So if you look up the formula for GPE, then you're going to see that the change in gravitational potential energy is equal to mg delta h, right? So delta GPE is equal to 19 times by g. You can read that off the front cover of the test, where it says that the acceleration due to gravity is 10. Okay, and then we need the height. Oh, careful, look, that's in centimeters. So to convert that into meters, we've got to divide this number by 100, okay, which gets us 6.3. 6.3, there we go. So if you multiply all of that together on a calculator, you'll get like 1,197, okay. But again, we've got to be careful here, all right, because if we look back at the question, look, that was to two significant figures, okay, and that was to two significant figures, all right. So that means that we should be giving our answer to two significant figures, right? So the best answer here is 1,200. And because this is energy, the units that we're going to need are joules. Now, this question here, it says state, all right, which means that you should just be able to write it down. You don't need to do any calculations, right? There is a formula, and it is that the GP at the top is equal to the KE at the bottom plus any work done against frictional forces, right? Any work done against friction. But it says that we can ignore the effects of air resistance, so this term just disappears, right? And now we see why we could just write it down, because the GPE at the top is equal to the K at the bottom. So we can just write it down, 1,200 joules. Closer to the ground, the effects of air resistance cannot be ignored. So when the bag's traveling at a constant speed, the air resistance equals the weight of the bag, right? So, I mean, they're even telling you what to do here, right? The air resistance force upwards, sorry, that's not very clear, not very drawn very well, is it? Okay, is equal to the weight downwards, right? So these two forces have got equal magnitude, okay? So if we want to calculate the size of the air resistance, all we've got to do is calculate the size of the weight. But we know a formula to calculate weight, which is mg, okay? So that means that the air resistance is 19 times by 10, okay, which means that the air resistance is 190. Don't forget the units. Okay, it's a force, so the units are going to be in newtons. So the bag hits the ground and stops without bouncing. So it was falling down and then it's hitting the ground, right? So, you know, this is where it's, so this side is where it's just about to hit the ground, and then B, C, and D is after it's hit the ground, right? Okay. So when it's falling, what sort of energy has it got? Okay, it's got kinetic energy, it's got movement energy as it's falling, right? Okay. And then you can see here, when it lands, all right, then the ground is going to get heated up, okay? And that's C, right? So that's energy being transferred mechanically to the ground's thermal store. So if the ground gets hot, okay, then I think, you know, I think it's okay for us to assume that the bag's going to get hot as well. So this is why this one is thermal, okay? And if you take your hands and you clap them together like, you know, 1,000 times really fast, and then you hold them up to your face, you'll find that your hands are actually a bit hotter, okay? You can feel the warmth on your hands. And then the clapping of the hands, you know, this bag hitting the floor, hopefully that's giving you another clue. What's D? It's going to be energy transferred by sound radiation. Okay, sound radiation to the surroundings. Okay, now I think my answer's better than their. Whoops, sound radiation. I think my answer's better than their answer because they just say biradiation, which can obviously mean light radiation as well as sound radiation. Okay, I think my answer's a better answer there. And that's the end of question 4.